Guys. Okay, so we're going to start with our solving rational equations and inequality. So the first thing that we want to be able to do is to take our rational function g of x, and the graph is pictured at the right, and then we're going to be able to answer questions 1 through 5. So on number 1, it says g of x is equal to 0. So we're looking for the x-intercept. Okay, so just remember that that is what we're looking for when it says equal to 0. So we can take a look at that on the graph, and we can see that x is equal to -1. And by the way, this is just over here off to the right. We can see that g of x is factored right here. All right. Now I color coded um, where the function g of x is greater than 0. And so we're just going to put that in interval notation. So we're going to write that as -infinity to -3. Pick back up on the other side of -3 and go to -1. Do not include -1 because it doesn't say greater than or equal to 0. And then we are going to pick back up on the other side of that vertical asymptote at +1, and we are going to infinity. Okay, so that's going to be our interval. Notice the parentheses instead of the brackets. So now we're going to take a look at the purple, or pinky purple, and we're looking where the function is less than 0. So the function is less than 0 from -1 all the way to +1, where that vertical asymptote stops. And then now we've done this before. The only difference between 1 and 4, or I'm sorry, 2 and 4, is that now we are including the equal to symbol. So where is the function greater than or equal to 0? So where is it above the x-axis, including the x-axis? So what we have is going to be from -infinity. It's just going to be just like number 2, but we're going to have brackets in certain places. Now, again, we can't include -3. Notice that that's a whole. So we're not using brackets on -3, but what we are going to do is use the bracket at -1, because the -1 value is what makes it 0. And then we pick back up on the other side of that vertical asymptote, and we go all the way to infinity. And now we're going to take a look at number 5, and we're talking about how 3 and 5 are very similar. Just now we're going to include 0. So let's take a look at this. Where is the function less than or equal to 0? So we're going to include the point -1, but we cannot include +1 because that is a vertical asymptote and we are not going to be able to touch that. All right, so let's take a look at this section right here. It says, the goal of the lesson is to learn a strategy to algebraically solve rational inequalities. And the process is identical to solving polynomial inequalities with one exception. And we're going to go over that. It says, given the function g of x, find the function values g of -3 and g of 1. So you can see that I went ahead and when it says find the function values, I went ahead and performed the math, right? So I'm just plugging it into the equation, and something interesting happens. On the first one, I get 0 over 0, which is undefined, okay? And then on g of 1, and there's a more precise words for 0 over 0, but for right now, the bottom line that you need to be aware of is that it's undefined. And then g of 1 is 8 over 0, and this is also undefined. So there's two ways to be undefined. And just as a reminder, remember that when you're dividing by 0, it's okay if 0 is on top. It's no if 0 is on the bottom. Okay, so there's two types. You can get 0 over 0, and you can get a number divided by 0. And we will talk about that a little bit more in depth later, but those are the two conditions in which you can get undefined. Okay, so it says using the graph above, explain why your efforts to find the values g of -3 and g of 1 had the outcome that they did. Well, what do we notice when at x is equal to -3 on the graph? So when x is equal to -3, what do we notice? Um, I notice that there is a hole. And so I'm going to put that in here as soon as my computer responds. Okay, so at x equals -3, there is a hole. And it's basically not an included point. Okay, and at x equals 1, there is a vertical asymptote. Okay. All right, so both situations make this function undefined. Actually, it's not undefined. It's actually discontinuous. So we're going to get into that later too. So whether you have a hole or whether you have a vertical asymptote, that is the part that makes the function discontinuous. So it's you can't just trace the graph with a pencil. So it's discontinuous at x equals -3 and 1, which will happen if the function is undefined. So when you have something that's undefined, that's where the function is becoming discontinuous. All right, so if we completely factor this function, which we did here, it says identify the values of x that make the function equal to 0 and the values of x which make the function undefined. Well, remember when something is undefined, then that means you're dividing by 0. In order to make it 0, so let's put this right here. 0 must be on top in order for it to equal 0. Excuse me. And 0 is on the bottom in order for it to be undefined. So let's take a look, and I'll do orange so we can color code. They're asking where is the function equal to 0? Well, if I take a look, what I notice is this portion right here, the x plus 3's, they are actually going to cancel out. So the part that's going to make this a 0 on top is going to be x plus 1. And so I get x is equal to -1. Now, if I come back over here and look at where it's undefined here at the bottom, right? So what are the x values that are going to make that a 0, and what are the x values that are going to make this a 0? So what I have is x plus 3 cannot equal 0. And then x minus 1 cannot equal 0. And the reason I say cannot is because the fact that it's undefined. So basically, you're kind of finding the restriction. So x cannot equal -3, and x cannot equal 1, because if they did, it would make the function undefined. So let's take a look at what's happening over here. So we're doing our number sign analysis. Okay, so this process is identical to what we use with polynomials. However, and this is the part that's important, not only is our number line going to be divided by where we put the function equal to 0, but also using the values that make the function undefined. And so this is the part where it is going to be new. So what we want to do on step number 1 is obviously completely factor, which you can see here that I did, making sure that you are copying the original problem, which says where is the function less than or equal to 0. So what we're going to do now is we have to set each factor equal to 0 to find the zeros, and then also where the function is undefined. So if we take a look at our zeros, let's look at the numerator. The 0 is going to be x is equal to -1. And then we also can see that x is not allowed to be -3, and x is not allowed to be positive 1. And you can see when I put a slash through that equal sign, that's going to indicate the undefined portion. So now let's draw our number line. So we're going to put -3 here. But I want you to circle these and I want you to put a slight X over it because that's going to help you remember which one is a 0 and which one is undefined. So here's -1. We don't need an X through that because that's the 0. And then here's +1. And we want to put kind of like an X through that so we can keep track again of undefined or zeros. So now what I'm going to do is I'm just going to say, well, x is going to equal -4. I'm just picking a number in between the interval. And then I'm going to perform my sign analysis. So I just get ready to do my parentheses and my factors, getting everything set up so I can just figure out my signs. All right, so here we go. When I plug in -4, into each one of these guys. -4 plus 3 is a negative, -4 plus 1, and then I've got -4 plus 3, and then -4 minus 1. And so you can see now that what that gives me is I've got a positive over a positive, and so that's going to give me a positive portion of my interval. Now I'm going to do that for x is equal to -2. So -2 plus 3, -2 plus 1, -2 plus 3, -2 minus 1. And so when I simplify that, that's going to be a negative over a negative. And so again, that is also a positive. Okay, so now let's do 0. 0 plus 3. Oops, I'm going to color code that. 0 plus 3, 0 plus 1. 0 plus 3, 0 minus 1, so that's a negative. So I've got a positive over a negative, and so that interval portion is going to be a negative. And then now I'm going to do 2. So I've got 2 plus 3, I've got 2 plus 1, I've got 2 plus 3, and 2 minus 1. Well, that definitely looks like it's going to be a positive over a positive. And so that's going to be positive on that interval. So remember, the whole point is to be able to answer that question. All right, the original inequality symbol was less than or equal to, which means negative or equal to 0, which occurs on the interval. So now this is where we have to go back up and look for this particular section where the function is negative. Now, it is negative in between these two guys right here. This -1, which is a 0, and then we've also got the +1. Now, we can't include the +1 because it's undefined, but we definitely can include the -1 because that's the 0. All right, so now this is going to be kind of like the template that you can utilize to answer the questions here. It says, excuse me, now refer to this graph. Explain how our sign analysis is confirmed by the graph. So let's take a look, and I will try to color code this here. Let me do green here. And I'm looking at where the graph is above. So it's where it's positive. So it says here on the intervals from, here we go, -infinity to -3. And then we could do our union. We got -3 to -1. And from 1 to infinity, g of x was positive, right? So we can even look up here. From -infinity, which is where we start our number line, right? I guess I can do this. -infinity to -3. From -3 all the way to -1. and then from 1 to infinity, my number line or my graph were positive, which means it's above the x-axis. Okay. All right, so now let's take a look at, let's do orange here. And so this is the portion where it's going to be negative. So if I look at my number line analysis, it's negative from -1 to 1, but we have to be very careful on how we write that. So on the interval from -1 to 1, g of x was negative, and the graph is below the x-axis. Okay, so that's how you're going to connect your algebra to the graphical connection here. All right. All right, so now let's take a look at this one. It's already nicely factored for us. So what we need to do is to be able to identify those zeros. All right, so I'm going to have a 0, x equals -3. I have x is equal to 1, and I notice that x cannot equal -2, which is where is this undefined, right? So x plus 2 cannot equal 0, therefore x cannot equal -2. That's where I get that. And now I'm just going to take this idea and put it into that number line. So ordering them, again, I'm circling my zeros, and then I put an X through my vertical asymptotes. Um, and then I've got X is equal to 1. Okay. And so here I'm going to pick, oops, I want that a different color. X is equal to, I'm just going to do -4. Here I'm going to do -2.5. Again, we're not finding the actual value in this particular instance. I'm just picking these, any number in between the interval. All right, so now I'm just going to perform my sign analysis. There's 2 factors on top and 2 factors on the bottom because of the squared. So I'm just setting it up to be able to plug in my numbers. So if I have -4 and I plug in -4, I'm going to get a negative, and then another negative, and then another negative, and then another negative. So what that gives me is let me get this in black here. I'm simplifying. Gosh, my computer is really slow today. A positive over a positive, which gives me a positive interval in this case. Let's go to do -2.5. All right, so if I go -2.5 plus 3, it still gives me a positive. Right here, that's going to be a negative. A -2.5 plus 2, those are going to be negatives. So now I've got a negative over a positive, so that's going to be a negative. And I'm doing 0. Again, I'm just plugging 0 in mentally just to see what kind of sign I get. And then I can come here and go, it's a negative over a positive, which means it's also a negative. And then again, positive plus a positive, 4 minus 1 is still a positive, 4 plus 2, 4 plus 2. So it looks like I have another interval where I've got a positive and a positive right here. All right, so with that, we're going to go back and answer the question. Remember, the whole idea was to be able to look at this inequality and answer the question, where is the function less than 0? So less than 0 means negative, which occurs on which interval. So if I take a look, I'm going to try and color code this to be orange. This negative occurs right here on this interval and on this interval. Okay, so the question is, can I go from -3 all the way to 1? That would include the -2. And because that is undefined, I have to separate that. I cannot include that in the interval. So it's -3 to -2, not including the -2, and then going to 1. So now if I take a look at that, I can answer the questions about the graph. It says on the interval, so let's take a look at this here. I'm going to do a different color. I think I did green, right? So I'm going to look where it is positive. Okay. So on the intervals from -infinity to -3, and from 1 to infinity. Again, all we are doing is using our sign analysis that we did above to answer the questions about the graph. The g of x is positive, and the graph is above the x-axis. So let's take a look at that interval on our number line. So we got -infinity to -3. Boy, my computer is really slow. Sorry for the lagginess. So let's just take a look on our number line. We had -infinity to -3, and then from 1 to infinity. And that's the green portion. And now let's take a look at the orange. And so if I'm going to answer that question, on the intervals from -1, oh no, that's not -1, that's -3, sorry. From -3 to -2, right? That's this side of the graph. Can't include that, right? And then from -2 to 1, g of x is negative, right? And the graph is below the x-axis. All right, so we are almost done here, and then I'm just going to go through and be able to look at this one here. Hopefully you recognized on this one here, take a moment, process that. We need to factor this, right? So I've got x minus 3, but if you notice, I can't factor x squared plus 4x plus 2. So what I'm going to do is, I need to solve it. So I'm going to bring in the quadratic formula. Okay, so as I do the quadratic formula, and you can pause the video and look at the work, I find out that the bottom number, so x cannot equal, right, my denominator cannot equal -2 plus rad 2, and then also -2 minus rad 2. So the whole point is to be able to answer the question, where is the function greater than or equal to 0? So I'm going to do my number line. And I've got my zeros, which is x is equal to 3 from the numerator. So what I've got here is -2 minus rad 2. That's going to be the smaller number, and I'm going to put an x through it. That's an undefined value. And some of you got to make sure that you understand how to approximate this value. So just real quick, if I were to take rad 1, rad 2, rad 3, and rad 4, I know that this is 1 and this is 2. The halfway point would be right around here. So this got to be less than 1.5. So Maybe it's approximately 1.3, 1.4, something like that. And then this could be, again, it's just an estimation, something above 1.5. So it could be like maybe 1.6, it could be like 1.7 or something like that. So all we're trying to do is be able to order them from least to greatest. Okay. All right. So now what we're going to do is we're definitely not going to use factors because this isn't really factorable and we're all about efficiency. So let's take a look at see what would happen if I were to plug in, let's just say -4. hmm, X equals -4 in this interval. um, X equals, and again, you have to make sure you pay attention to this interval. This number right here has got to be at least -2 minus 1.5-ish, right? So that's like a -3.5 right here. And then this guy right here is like a -2 plus 1.5. So that's like, a -0.5. So I've got to pick a number that fits within that range. So I'm going to pick -1. And then, of course, from a negative to a positive, it's always nice to try and do a 0. And then I can come over here and do x is equal to 4. So that's just the idea behind picking those numbers. Okay. All right. So again, I have a lot of lag time, distance learning, right? Okay, so what we're going to do here is not necessarily do a lot of plugging in, but if I take -4 minus 3, I definitely know I have a negative on top. And then if I were to take a -4, so this is what I'm doing right here. I'm going to take like -4 squared plus 4 times -4 plus 2, 16, and then this gives me -16, and then I end up with a positive. So this is a positive, which means the overall interval is negative. Okay. And so let's go ahead and do that with x is equal to -1. So I've got -1 minus 3 is a negative. And now let's try that. So squared plus 4 plus 2, so -1, -1. I got a +1. I've got a -4 and a +2. So that's going to end up giving me a negative. And so when I simplify that interval, that gives me a positive. All right, so now I've got 0 minus 3, which is going to be a negative on top. And then I've got, obviously 0 is going to make it super easy. I just left with a positive. I'm sorry. I'm left with a positive on the denominator, but the overall interval is going to be negative. And then last, I'm going to take a positive, square it, add another positive, add another positive. So my denominator is going to be positive. Let's take a look at the numerator. 4 minus 3 is still positive. So what I'm going to do is have a positive interval here. And once you're done with the identifying the portions of where the function is negative and positive, we go back to the directions. I'm looking for where the function is greater than or equal to 0. So when that means that it's positive, so I'm going to highlight this interval and then this interval on my number line. If that makes it easier, you can also underline this portion. Remember, if it's a undefined value, you can never include it. So what we're going to do is have -2 minus rad 2 all the way to -2 plus rad 2. Cannot include it, even though it says greater than or equal to 0, because those are undefined values. And then what we're going to do is pick back up. Now we can include 3 because that's a 0. 3 to infinity is going to be our notation for that. Okay. So that's kind of a little bit longer one. Let's take a look at this little bit simpler one. It's already factored for us, yay. So let's identify the zeros. So x is equal to -1/2, and then x is equal to 3. X cannot equal -2, right? Because that's what's going to make it undefined. So let's do our number line here, putting them in order from least to greatest. I've got -2. Remember, cross that out so that you can keep track. I've got -1/2. I'm going to circle it because it's a 0. And then I've got a 3, and I can circle that, and it's also a 0. So now I'm going to pick my x values. I'm going to just say x is equal to -4. X is equal to -1. X is equal to, I don't know, I like 0. And then x is equal to 4. All right, so what we're going to do is just keep that separated, draw those lines down, do your work within the lines. Here we go. I'm going to set up my parentheses. I've got 3 parentheses on top and 2 on the bottom because of those exponents. So I'm just setting up for my sign analysis right now. All right, so I'm going to take a -4 times 2. Ultimately, that's going to be a negative right here. A -4 minus 3 is also a negative, and then a -4 plus 2 is also a negative. So ultimately, you guys will see that I've got a negative divided by a positive, and then that ultimately is going to give me a negative on this interval. Going back using x is equal to -1, that is going to give me a negative here. -1 minus 3, then -1 plus 2. So those are my signs right there. So I have a negative over a positive. And again, that's going to be a negative. Okay, now we're using 0. So I've got a positive, a negative, negative, and then a positive, positive. So here we go. You can see that that interval is going to be positive. And then last, 4, we're going to add, this is going to be positive, and then positive, positive. So my last interval is positive. So again, this is where you need to go back up. Don't forget about the directions. The question was, where is this function less than 0? So where is it negative? Well, it's negative from here, right? So negative, negative. So I can do this number line here. And so the problem is, in between these two guys, there's that undefined value. So you have to break it up. So it's going to be -infinity to -2, and then from -2 to -1/2. And it's not a bracket because I didn't say equal to. It's just less than 0. All right, last one. Now this one looks a little bit intimidating, but this just combines your algebra skills in this case. So when you guys go to do a rational, you're just going to rewrite it. So 3 over x plus 2, we're going to move this over to the other side by subtracting it. And we keep the sign. It was less than or equal to, but when we move that over, it's now 0. Okay. So if you remember how to add fractions, you need common denominators. So I need my common denominator to be x plus 2 and x minus 1, which means I need to multiply this guy by x minus 1 and this guy by x plus 2. And so when I perform that calculation, I'm going to get 3x minus 3. And then I also get minus 2x minus 4. Okay, because I'm taking that -2 and distributing it. And so that ends up giving me x minus 7 over x plus 2, x minus 1, and it's less than or equal to 0. So a little bit of work to get here, but once we're here, it's easy to find those zeros. So we can say that x is equal to 7, x cannot equal -2, and x cannot equal +1. So for us, now let's go ahead and do our number line. So we've got -2, exit out. We've got a 1, exit out, and then we've got a 7, and then just circle it. Okay. So from here, I'm going to say maybe x is equal to -3, maybe x is equal to 0, and then x is equal to 4, and then x is equal to 8. And so I'm going to draw my lines here. And then let's do our signs. So we've got 1 factor on top, 2 on the bottom. And so -3 minus 7, and then -3 plus 2, and then -3 minus 1. So that's going to be a negative over a positive, which is going to be definitely a negative. So 0, that's going to give me this sign analysis here. So it's a negative over a negative, which is going to be a positive. And then I've got 4 minus 7, so that's going to be a negative. 4 plus 2, 4 minus 1. So if we look at that, we have a negative over a positive. So that's going to be a negative interval. And then 8. So we've got 8 minus 7 is finally positive. 8 plus 2, 8 minus 1. So what we have is a positive over a positive, which gives us that positive. Now, remember, go back and answer the question. Where is the function less than or equal to 0? So where is it negative? So it's negative here and here, also including 0. All right, so what we're going to do is we're going to have negative infinity all the way to here, but it's an undefined value, so I cannot put brackets on it. Then I come back here. It's also an undefined value, so I cannot put brackets on it. I end here at 7. It is a defined value, so I can put brackets on it.